Hello everyone, and welcome back to the Fluctus Channel. Japan's Shin Meiwa US-2 is one of the most unusual rescue aircraft in the world because it is built to go where ordinary patrol aircraft cannot land. It is an amphibian, able to operate from a runway or from the surface of the sea, and it was designed for Japan's Maritime Self-Defense Force to reach people in danger across Japan's wide stretches of ocean. Its long, high-wing, boat-shaped hull, 4 turboprop engines, and extra boundary layer control system give it the short takeoff and landing performance needed for rough maritime rescue. The aircraft is about 33 meters long, has a wingspan of more than 33 meters, and can operate in seas with waves around 3 meters high. That makes it especially valuable for island nations, where a medical emergency, ship accident, or downed aircrew may happen far from a runway. Instead of dropping supplies and leaving, the US-2 can land close to survivors, bring rescuers aboard, and fly them directly to much-needed care. When US Air Force personnel trained with the Japan Maritime Self-Defense Force, the first step was understanding the aircraft before touching the water. A US pilot entered the Shin Meiwa simulator, where controls, displays, visibility, and emergency procedures could be studied safely. The simulator recreates approach angles, sea state judgment, power settings, and the unusual feeling of managing an aircraft that must behave like both a flying boat and a land plane. Search and rescue training then turned the classroom idea into a combined mission. Japanese crews prepared the US-2, while American airmen observed procedures, communication flow, and aircraft handling. Before launch, crews reviewed weather, sea conditions, fuel, route, and rescue objectives. On a real ocean mission, those decisions decide whether the aircraft can land safely or must remain airborne. After takeoff, the US-2 flies like a large turboprop aircraft, but the final approach is where its design becomes critical. The crew descends toward the water, reads wind and wave direction, aligns the hull, reduces speed, and uses the boundary layer system to keep lift at low airspeed. Contact with the water must be controlled, because the sea is not a runway. The hull meets chop, spray climbs over the nose, and pilots manage power to keep the aircraft stable. Once stopped, the aircraft becomes a rescue platform. Crew members open hatches, prepare medical space, lower equipment, and coordinate with boats or survivors. In a bilateral exercise, the value is not only the aircraft. It is the shared rhythm between US and Japanese forces, who communicates, who searches, who lands, who recovers, and who evacuates. The US-2 proves that in the Pacific, rescue power must cross air and water together. This familiarization also helps planners compare rescue options. A helicopter can hover, but range and payload are limited. A patrol aircraft can search far out, but cannot land beside survivors. The US-2 sits between those choices, making it valuable during maritime disasters where minutes, distance, and sea state decide success in emergencies. The V-22 Osprey gives Japan and the United States another way to solve the same geography problem. Japan is an island nation with remote areas, disaster-prone coastlines, and military responsibilities spread across long distances. A conventional helicopter can lift vertically but is slower over distance. A fixed-wing transport flies faster but needs a runway. The V-22 tilts between both worlds, taking off like a helicopter and then rotating its nacelles forward to fly like an airplane. Japan became the first foreign military customer for the V-22, selecting it for the Japan Ground Self-Defense Force. The purchase reflected a need for rapid transport, island defense, disaster response, and amphibious support. U.S. Marines already operated MV-22B Ospreys from bases in Japan, so Japanese crews could watch a mature tiltrotor system working in the same regional environment. The delivery process showed how major aircraft enter a country before they begin flying. In February 2021, JGSDF V-22 Ospreys arrived by ship at Marine Corps Air Station Iwakuni. The air station's deep-water port and aviation facilities allowed the aircraft to be offloaded from a vessel, moved ashore, inspected, and prepared for functional checks before flying to their final destination. This is not a simple parking job. The aircraft must be secured during sea transport, unloaded carefully, checked for damage, serviced, and cleared through maintenance procedures. When a V-22 prepares to depart, the crew works through a sequence that mixes helicopter discipline with airplane systems. Maintainers inspect rotor blades, nacelles, landing gear, hydraulic lines, fuel, avionics, and control surfaces. Crews brief the route, weight, weather, and emergency landing points. As the engines start, the large prop rotors turn above the aircraft, creating powerful downwash. Ground personnel maintain distance, while pilots bring systems online. The takeoff begins vertically, or with a short rolling movement, depending on the mission and weight. After climbing, the nacelles rotate forward. The aircraft accelerates, leaving helicopter behavior behind and entering fixed-wing flight. That transition is the heart of the Osprey's value. It can lift troops from confined areas, then cover long distances faster than traditional rotary-wing aircraft. Aerial refueling extends that reach even further. During marine refueling operations, an MV-22 approaches a KC-1 30J tanker, stabilizes behind the hose, connects its probe to the drogue, and receives fuel in flight. The pilot must hold position while turbulence, airspeed, and aircraft movement change constantly. With tanking, Ospreys can move farther across the Pacific, support expeditionary operations, and keep island forces connected when runways are damaged or unavailable. For Japan, the aircraft supports a larger defense shift. It is not just a transport, It is a bridge between islands, ships, bases, and disaster zones, giving commanders more ways to move people and equipment where speed matters most. The system also demands trust from communities around the base. Tiltrotors are loud, complex machines, so crews train, explain safety procedures, and prove reliability through repeated operations. Each launch, landing, and maintenance check helps integrate the Japanese fleet into US-Japan cooperation across the first island chain. The Kawasaki C2 gives Japan heavy airlift built around range, payload, and rapid response. Developed by Kawasaki for the Japan Air Self-Defense Force, it replaced older C-1 transports with an aircraft large enough for modern equipment and long-distance missions. Official Kawasaki specifications list the C2 at about 43.9 meters long, with a wingspan of 44.4 meters and a height of 14.2 meters. Its mission is strategic and tactical airlift. Japan needs to move vehicles, cargo, disaster relief supplies, personnel, and equipment across the home islands and to overseas missions. The C2 uses two high-bypass turbofan engines, a rear loading ramp, a high wing, and a large cargo hold. The design allows pallets and wheeled cargo to roll in, be restrained, flown, then unloaded quickly at the destination. A semi-prepared runway demonstration test highlights why that matters. A cargo aircraft may not always have the luxury of a perfect concrete runway. Earthquakes, storms, conflict, or remote deployments can leave only rougher landing surfaces. Before such a test, crews assess the strip, check surface firmness, calculate aircraft weight, review braking distance, and prepare for dust, debris, and uneven rolling resistance. On approach, the C2 must descend steadily and align early because a heavy transport cannot be thrown around at the last second. The landing gear absorbs the touchdown, engines reverse or decelerate, brakes engage, and the crew keeps the aircraft centered while the runway surface tests every tire and strut. After stopping, crews inspect the aircraft for damage and study how the landing surface reacted under load. This kind of test supports disaster response and military mobility. If a runway is damaged but usable, a C2 can bring relief supplies, generators, water, medical gear, or security forces, where smaller aircraft would require multiple trips. In a regional emergency, the aircraft becomes a national lifeline, carrying heavy cargo over long distances without depending entirely on foreign transports. The aircraft supports peace cooperation. Crews can load humanitarian cargo, deploy medical teams, or move equipment after typhoons and earthquakes. Its size gives decision-makers options when speed and volume must arrive together. Japan's F-15 fleet represents the high-speed defensive side of the same air power network. The F-15J was produced in Japan by Mitsubishi Heavy Industries under license from McDonnell Douglas, giving the Japan Air Self-Defense Force a powerful air superiority fighter tailored to protect national airspace. For decades, these aircraft have scrambled from Japanese bases to identify, intercept, and monitor aircraft approaching the country's air defense zone. A scramble begins with alert crews waiting near ready aircraft. Maintainers remove pins and covers, check the area, and help launch the jets safely. Engines spool, control surfaces move, and the fighter taxis toward the runway with speed and urgency. Once cleared, the 15 accelerates hard, lifts away, raises gear, and climbs toward the intercept. In maneuver flight, the aircraft's power is clear. Twin engines allow rapid climb, sharp turns, and high-speed positioning. Pilots practice formation changes, brake turns, intercept geometry, and defensive reactions, building the judgment needed when a real, unknown aircraft appears near national airspace. The F-15J may be decades old, but it remains a serious air defense platform because speed, radar, missiles, and trained pilots still matter. Japanese aggressor units add another role. These pilots imitate potential enemy tactics during training, forcing friendly pilots to face harder, less predictable opponents. An aggressor aircraft may fly unusual profiles, challenge radar setups, and test how quickly defenders can recognize a threat. Behind every scramble is maintenance. Engine teams inspect intakes, fan blades, fuel systems, exhaust areas, and panels. A fighter that cannot launch in minutes is not an interceptor. From the US-2 landing on water, to the V-22 crossing islands, to the C-2 hauling cargo, and the F-15 defending the sky, Japan's aircraft show a force built for rescue, mobility, and rapid reaction across the Pacific. Together, these aircraft strengthen Allied readiness across the Pacific every day and during the successful completion of every single emergency. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.